One more thing, I do teach marketing and branding at the new school in New York City right now.
Mark's pretty good at everything. So what are we doing? We're developing new drone hardware technology. So most drone companies that are out there primarily tweak the software of the drone for new applications. We are fundamentally changing the hardware of drones, the way it works, for even broader applications to expand the horizon, increase efficiency, lifting capability, speed, and range. You can only do so much with software, but with hardware changes, you can do quite a bit more. So there's a lot of different new technologies that we're working on. The first is what you see here. Essentially, what we're doing here is using turbine power for the lift aspect of a drone. Now, your normal quadcopter drone, that 95% of the drone market is filled with, it's essentially these four blades here, and they're what provide the lift for that drone. Somewhat inefficient, they don't travel very far, it's 22 minutes if you're lucky on battery. This turbine takes the lifting aspect out of those fans, and the fans are just used for directional. Not only that, it's far more efficient, so you're using the turbine for speed. Essentially, what this yields in the real world is much further range, much heavier lift. We're talking 200 kilograms versus what's out there right now, which is 2 to 5 on a maximum basis. Much faster speed, and a various number of other enhanced capabilities. So Mark can talk to that in a little bit more detail, and he can show you guys a demo of what we've got here.
So this is the third prototype in a series. And again, basically, we've decoupled the lift from the control of the drone. So we have a very efficient turbine. You know turbines are efficient because they're what's on the 787 that you're flying to your next business location. They use them on planes for a good reason. They're reliable and they're efficient. And what we've done is we've taken 95% of the lifting force that's needed to lift this drone and transferred it from these outer motors to the turbine. The nice thing is, if you want to lift more, instead of having to spin bigger propellers, which is what you normally see on drones, all we do is drop in a bigger turbine. 120 millimeter turbine, this is a 70 millimeter. 120 millimeter turbine will lift about 200 kilograms. And the footprint is only about 4 feet. So it's very, very simple. I'm going to go ahead and spin this turbine up to about half power. Now, of course, we're not going to light a Jet A turbine in the room today. So we're spinning just the compressor. So if you're on an airplane, you can hear sometimes the compressor spin up electrically. We're going to spin up just the compressor on this turbine. The Jet A turbines are a lot more powerful, and you'll get an idea. I'm going to spin it up only to half power, just to give you an idea. This is anchored to the table, so it's not going to go into the air.
The table will fly off.
However, you want to hold on to your glasses if you have glasses in front, because it does get a little powerful. So I'm going to turn on a control here, and I'm going to connect it. We're going to run it on battery power today, and I'm just going to connect up the batteries right here. And those tones you're hearing are just the computer telling us it's all right. So again, we can spin this up to about half power, and hopefully you'll feel a little bit of the breeze that comes out of here. And again, we can do anything a drone can do, and the way we test this, which is really cool, right, is we're a lean startup with no money and no manufacturing facility. I actually went to the store and bought a whole bunch of happy birthday balloons, helium balloons, and attached them to the drone and flew it with helium balloons holding it up. And when the computer didn't care, I knew we had something really good. So here we go. How powerful this is, right? I'm going to spin it down again. That's about half power. Okay? You can see why suddenly this opens up a whole new world of opportunity. So I'll let Steve show you a little bit more about what we're doing. But this is the basis for a whole new category of drones.
And just to talk a little bit about some real world aspects of this, most of the quadcopter drones I mentioned can carry a maximum of 2 kilograms. This is 200. So you're talking about carrying a small package. This can expand the envelope to what we would call heavy lift. Question.
Do you think it's Amazon Prime with their you think that would be an application for this technology?
We've been thinking about that. There's definitely still some challenges. Well, I'll save all the questions till the end. It'll be a long Q&A. It's a good question. It's a good question. So we don't have a picture for this. Mark, you can probably talk to this.
Picture, I don't know.
I was supposed to put the picture in the PowerPoint and I forgot.
No problem. Yeah.
Sorry, guys.
Well, this is the great thing about iteration. The amazing thing now is we live in an amazing world where we 3D printed most of the parts that are on here. We 3D print them right here. One of our labs is right here at the Serendipity. But all kinds of new problems come along, right, when you start to lift heavy objects and fly fast. And I mean really fast. So once you get above about 0.3 Mach, air starts to behave a little bit differently and starts to get a little bumpy. You've all been in clear air turbulence in big airplanes. You can imagine a light airplane. Have you ever tilted your iPhone and it doesn't or your phone, it doesn't turn the picture? Right? You have to sort of wiggle it to turn the picture. The sensors in it get a little out of whack. And when you're going really fast and it's shaking around like this, it really there's so much noise in the sensors, it just destroys your ability to do it. So one of the things we've had to do is create a way to dampen the vibration. Damping the vibration is a little bit difficult when you're going that fast and you're up in the air, something to damp it against. So we use a very similar system that you find for actually earthquake dampening. And if you want to learn more about it, you can look up Taipei 101. And the top of Taipei 101 is a giant, huge giant weight in the top of the building. Imagine that. A big weight in the top of the building, and that weight is called a mass damper. And it sits on the top of the building, so when there's an earthquake, the building might shake, but that weight just stays stationary and helps dampen out the shaking. We use a similar technology to dampen those vibrations at very, very high speed, so that the computers and the sensors in the drone and the fuel systems are all protected, including the turbine.
So what you see here is, I believe, a third generation prototype. We've got a fourth in development, and this is the fifth in design. It's a much larger turbine with some other aspects that we're incorporating just to show you guys that we're thinking about future concepts as well. So I went over this a little bit in discussion, but there's a lot of potential aspects for this technology. There's high-speed kinetic, over-the-horizon recon, over-the-horizon target illumination, ultra-heavy lift. I mean, you're talking lifting things that normal drones are way beyond we can do. High-speed transport, we can get from point A to point B a lot faster than any drone that's out there. Cylindrical payload, ocean surveillance, Coast Guard, someone who's lost out at sea, you can get to point A to point B a lot quicker. And transport and lift. And those are just some of the potential applications. Now, one specialized application that we've been working on, we've sort of branded as what we call sky squeegee. So if you guys ever see the people that wash windows, it's 2018, it's insane that they still do it from ropes and they're going up on story buildings, 10 stories, 15 stories with squeegees. It's unsafe, it's expensive, and it takes forever. Why not use drones before that? So this is a third generation prototype. This fourth generation is in design. Essentially what this device is, it's a window cleaning tethered robot using drone technology. So we feed power, water lines, and a tether from the top of the building down to the drone, and the drone vacuum sucks to the side of the building and begins to wash and squeegee the building.
That's crazy.
So again, it adheres to the building using air pressure. This is sort of the grand vision where you've got a ginormous skyscraper and you're running drones down the side of the building. The amount of money in this is incredible. It takes a very long time. I've done some initial research with buildings in Stamford, in New York. What they pay is phenomenal for window washing, and it takes forever. So essentially the business plan is quite simple. We can do it for half the price and still make a ton of money.
Right.
And also just another aspect of the technology, station keeping technology. So one of the aspects here, and we can't demonstrate it, we need too much equipment at the moment, but we are able to hover off of the building, go to the next window pane, and hover back on. And that's because we're using opposing forces in each direction. So we're able to create that soft landing on the window, move, clean that window plane, come back off, jump onto the next one. And that's it.
All right. That's pretty awesome.
At this point, we'll open it up to questions. Feel free to fire them out. Yep.
So you're comparing your technology to normal